Howdy! In this series, we're using AI to help us learn Elixir. We're speedrunning the Elixir track on exorcism.org using AI as our partner and trainer. Today's exercise is bird count. We're learning about recursion. We'll also get some practice with guards and pattern matching. I've gone ahead and given NotebookLM a link to the exercise and a copy of the hints and asked it to create a presentation video. A link to that video is in the description below. It does have a couple of rough spots, but overall it's an excellent presentation on the exercise and the learning goals. Hopping into VS Code for a moment, I've gone ahead and ran the prompt to have Copilot bring in the instructions from the README and examples from the test file so that we can focus in this one file instead of having to bounce between them. Bringing back Google's AI Studio as our real-time coach and mentor. We're going to start a real-time stream. We're going to use the native audio preview model. We'll use Corey for a voice. Turn on turn coverage to allow Gemini to see your screen even when there's not a conversation going on. Thinking is good. Effective dialogue allows the voice to be more expressive. Most importantly, grounding with Google Search allows Gemini to look up information to help answer our questions. Before we share our screen, I'm going to prepare a prompt to give to Gemini once we're started. It's long, but it's simple. It says, we're learning Elixir and wants Gemini to be our mentor. This is what we've done before with the system prompt. We give it a link to the exercise. Then we tell it we'd like an overview before we get started. And then lastly, hey, there are these hints and keep them in mind when guiding me towards the solution, which is why this is so long. This is just a copy of the hints file. So let's share our screen and begin. Hello, Gemini.
Hello. How can I help you today? The bird count exercise in Elixir involves implementing a module to track bird counts over different days. The counts are given as a list of integers, with the first element representing today's count, the second yesterday's, and so on. You'll need to implement functions to access today's count, increment today's count, check if there was a day with no birds, calculate the total number of birds, and count the number of busy days. The hints suggest using pattern matching for some tasks and recursion for others, particularly for iterating through the list. Which task would you like to start with?
Let's start with instruction 1, which is about the bird count for today.
Okay. Let's start with checking how many birds visited today. The goal is to get the first element of the list. The hints suggest using pattern matching for this. How can you pattern match on the list to extract the first element?
We saw this in a previous exercise where we can deconstruct that list to the head and tail and just return the head.
That's right. You can pattern match the list in the function definition to bind the head to a variable. Remember to also handle the case of an empty list. How would you write the function clauses for those two cases?
Right, so when the argument matches the empty list, we return nil.
Exactly. You've handled both the empty list and the non-empty list cases perfectly. The first clause matches an empty list and returns nil, and the second clause matches any non-empty list and returns the head. Great work!
All right, the next instruction is to increment today's bird count by 1. It says that when we're given an empty list, we should create an entry for today with the initial value of 1.
You got it! For an empty list, return a new list containing only the number 1. For a non-empty list, you'll want to increment the head of the list and prepend it to the tail. How about writing the code for the empty list first?
So we'll pattern match the empty list as the argument, and we'll return the list with 1 as the only entry.
That's correct. Pattern matching the empty list and returning 1 will handle the case where there's no data for today's count yet. Now you can focus on the case where the list is non-empty.
And we can pattern match the head tail like we did a moment ago, and then create a new list with the head plus 1, right?
Yes, exactly. Pattern matching the list into head and tail allows you to increment the head value and create a new list by prepending the incremented value to the tail. That's the right approach for a non-empty list.
All right, so it looks like we've completed increment day count, and we can move on to has a day without birds.
Sounds good. We can move on to has a day without birds now. What steps do you want to take to implement that function? It looks like it should return true if there's at least 1 day with 0 birds and false otherwise.
Looks like a pattern that we can leverage is to always deal with the empty list case first.
That's a good strategy. Handling the empty list case first often simplifies the logic for the recursive or iterative parts. What do you want the function to return for an empty list? The example suggests false would be correct.
Indeed, and I think I've implemented that function here on line 63.
Yes, line 63 defines has a day without birds list. How would you like to implement the logic for a non-empty list? You could think about pattern matching the head and tail, or perhaps using a function in Elixir's list module.
I was going to say we could match the head and the tail, but for one of the cases, we really care that the head is 0, and if that's true, we don't care what the tail is, we could just return true.
That's a good idea. You can match the head and tail and use a guard to check if the head is 0. If the head is 0, you found a day without birds, so you can return true. What about the case when the head is not 0?
Do I actually need a guard there, or can I just pattern match 0?
Pattern matching 0 is perfect for this case. You can define a separate function clause that matches 0, and true, and right away. Then your original function clause can handle the case where the head is not 0 and recurse on the tail. Would you like me to help you write that second function clause?
So I think that would look like this, that we don't care what the head is now because we know it's not 0. But what we want to do is check the rest of the list to see if there's any day in that is without birds. So I would call has without birds on the tail, right?
That's exactly right. The pattern match on _:tail will correctly recurse on the tail if the first day is not 0. With the base cases matching an empty list and 0 birds, this recursive approach will work for all valid inputs. Is there more code you'd like to review?
All right, well, I ran the tests for has day without birds and those passed, so it seems we've done all right. How about we move on to the total number of birds recorded in the list?
That's great that the tests passed. Moving on to the total number of birds, what steps do you want to take for that calculation? Do you want me to provide the solution or work through it together?
Definitely work through it together. If you just provided the solution, I wouldn't learn as much.
Great approach. Working through it together is a good way to understand the concepts. So, for the total function, what should the function return for an empty list?
Yeah, I saw this one had an empty list specification also. So it says when the list is empty, return 0. So I've implemented that function here on line 83.
That's correct. Returning 0 for an empty list is the base case. Now, how about the case when the list has elements? What's the next step in the recursion?
Well, it feels like we should start by deconstructing the list.
Yes, deconstructing the list is the way to go. How would you break a non-empty list into its head and tail?
So we deconstruct it with the bar operator here, and then for a value we want the head plus the total for the remaining tail, right?
That's right. Using recursion, you sum the head and recursively find the total of the tail. This approach will correctly calculate the sum of any list of numbers.
All right, and the tests for the exercise passed, so we can move on to the number of days in the list that are busy.
Okay, the next task is to count the number of busy days. A busy day is defined as a day with 5 or more birds. Looking at the examples, it seems like the function should return 2 for the first list and 3 for the second. How would you approach implementing this function?
Well, again, it's got a clause about it being an empty list should return 0. That seems important in these recursive approaches.
You're right. Handling the empty list is crucial in recursive solutions. Now, considering a non-empty list, how would you determine if the first element represents a busy day, and how would you combine that information with the count from the rest of the list?
Well, we can deconstruct the list to get the head called out separately from the tail. But we can't just put 5 here like we did when we were trying to match, because we really need greater than 5.
That's right. You'll need to compare the head of the list in the recursive clause to ensure it's greater than 5 to count it as a busy day. How would you represent that condition within the function definition?
Is that where the guard comes in?
Yes, exactly. A guard clause allows you to specify a condition that must be true for that particular clause to be executed. So you can define a clause for when the head of the list is greater than or equal to 5, and another for when it's less than 5. Would you like help implementing that?
So when it's greater than or equal to 5, we want to count that, so that's 1. And then we want to add that to however many busy days are left in the tail.
You've got it. That's the recursive step for counting the busy days. Now, let's handle the case where the head of the list is less than 5. What should the function do then?
Well, in that case, then we don't actually care what the value of head is, because it's going to be less than 5. So we just then want to get the number of busy days left in the tail.
Exactly. So in this less than 5 case, you would just call busy days on the tail of the list,
to continue the recursion without adding 1 to the count. That should complete the logic for the function.
Give this video a like to let me know it was helpful to you or that you simply enjoyed it. Join me next time for the high score exercise where we learn about maps and module constants.